Hello, my name is Olga Oakley and I'm from the Hands-On Science Center. We're really excited to be back here at the Williamson County Public Library to show another interesting topic of science. Today we're going to be demonstrating and looking at a few fun little experiment activities using liquid nitrogen. So we understand right now with the pandemic going on, we have to be closed to the public physically. However, we have a lot of very neat virtual content that will be available on our website. So today we decided to bring the science to you here at the library and everyone watching at home. So today we are going to look at liquid nitrogen. Liquid nitrogen is something that looks really, really neat and has a lot of really cool physical properties to it. All right, so first off, for safety, I always put my goggles on just to make sure that nothing really flies anywhere and doesn't want anything hit me in the eye or anything on the ground or anything like that. So first, before we look at liquid nitrogen, we are going to talk about what it is. So what is liquid nitrogen? Well, I'll show you first what it looks like a little bit. This is what it has. It has what looks like a fog, and if we just pour a little on the carpet, now if I did that with water, I'd be in a lot of trouble because we'd have a huge wet spot here on the carpet and I'd have to clean it up, or someone would have to help me clean up, and that would be bad. But with liquid nitrogen, it's very, very cold. So because it's cold and with the temperature difference, by the time it hits the floor, it boils off right away. So what are the physical properties of liquid nitrogen? Well, first off, all it really is, it's nitrogen. So if we look at what nitrogen is, it is part of one of four elements that are everywhere that are abundant in our universe, in our bodies, in the air, in space, everywhere. So we have carbon, hydrogen, oxygen, nitrogen. Hydrogen, oxygen, nitrogen. So nitrogen is everywhere. It's in our bodies, and it's in the air, and it's even in space too. It's pretty neat. So what is liquid nitrogen? Obviously, it looks a lot cooler than it does it just being a gas. Liquid nitrogen is very, very, very cold. It's very cold. So if you think about the coldest place on Earth, most kids would probably guess the South Pole or Antarctica or North Pole, where Santa Claus lives. It's in Antarctica is the coldest place that has ever physically been on Earth. At one time was negative 127 degrees. That's really cold. Today it's really hot out. It's probably about 90, 92 degrees Fahrenheit. So water boils at 212 degrees. That's how hot water boils. Nitrogen boils at negative 320 degrees. So if we want to take a look at how cold that is, another question we've had before was, what is the coldest temperature that has ever existed? So how cold could it ever get? Absolute zero is negative 460 degrees Fahrenheit. So what does that mean, absolute zero? That means at that temperature, all the molecules stop moving. They stop moving. There's no more wiggle room. Scientists for many different attempts have tried to get at negative 460 degrees Fahrenheit to absolute zero, but no matter how hard they try to get to that temperature, there's always still a little bit of wiggle room. To give you an idea of how cold space is 4 degrees warmer than absolute zero. And this is negative 320. So this is still warmer than absolute zero. But before we look at liquid nitrogen and see what fun things that we can do with it, let's talk about the air that we breathe. So if we take a deep breath and we exhale, what did we breathe in? 78% of what we breathe in is nitrogen. 21% of what we breathe in is oxygen, and then the other very small sliver of the gases that we breathe in is argon, carbon dioxide, and a few other little gases as well. So another question we have is, how do we get liquid nitrogen? How do we store it and contain it? And how do I bring it from Tullahoma, from the Hands-On Science Center here to Williamson County Library, which is about 80 miles away? And how do we bring it here? How did it not just boil off? So this is a dewar. Our dewar is a really good insulator, and this is what we use to carry and transport our liquid nitrogen. Another very great question we have is liquid nitrogen expensive? You would think so, just because of how cool, no pun intended, but how cool it looks and how cold it is. But all it is nitrogen that's compressed together really, really, really quickly in a pressure chamber to get all those molecules really, really, really close together. And at a very low temperature, negative 320 degrees, it turns into liquid. That's all it is. You just need a big expensive machine to turn it into liquid. But in terms of actually having the liquid nitrogen, it's very abundant. All right, so let's look at some cool things with liquid nitrogen, should we? All right, so first thing I'm going to look at is our little chamber. So what's happening here is liquid nitrogen, when it leaves the dewar, this insulator right here that we transport with, and it comes out and I pour it into this cup, it wants to get out of the liquid phase as quick as possible. It is very, very happy at a gas phase. So it wants to be a gas. It does not want to be a liquid. So it's very excited to. So as soon as I pour it into our little cup right here, it's expanding 696 times. Let's round that to 700 to make math and numbers a little bit easier. So another question we usually have from a lot of our field trips is, so liquid nitrogen looks really cool, but what's the use of it? Why is it made, and why do some people have it? Why do some facilities have it? Well, I don't know if any of you at home have any kind of warts or anything on your back, like a sunspot that you might want to get removed if you go to the doctor. So what they'll usually do is they'll have a liquid nitrogen gun that may be about this big. It's not this little Dollar General 50-cent Spider-Man cup, even though my son would really love to drink out of this, but it's something to show. So you might go to the doctor's office and say, I have some sunspots on my back. All right, let me get it there. And I have some right here on my shoulder. I might have one right here on my arm. And then they'll say, all right, great, that's $200. Let's come back in 2 months and let's do it again. So the lesson to that is, it's good to have good insurance. But if not for that, then stay out of the sun, especially if you're a child or you're in your younger years. If you save your skin now, it'll help you avoid going to the doctor and getting that liquid nitrogen on your back. And does it hurt? Yes, it does hurt on your skin, but that wart will come off. All right, so we didn't mention, let's look at some other cool stuff. We mentioned that liquid nitrogen expands at 696 times when it leaves this dewar. All right, so what I'm doing right now is pouring a little liquid nitrogen into this tennis ball canister. When I was in high school, I played tennis. I was on the tennis team, loved it. My favorite thing is when we would go to our meets and we would open a new tennis ball canister. So what we would do, usually it would come in a little can like this and have like a little aluminum tin on top, kind of like if you're about to open a can of tuna. You pop it open and then you would hear, whew, you'd hear that pop. So then your bouncy balls are really, really, really fresh. So what's happening is all that pressure is stored inside and it just pops right off. It really wants to get out of there. So what's happening exactly when liquid nitrogen is leaving its phase of liquid and going to its gas? It is wanting to go back into a gas because that's where it's happiest. So if I pour this liquid nitrogen in here, all the molecules, they are suddenly expanding. And they really, really want to leave here. So if you look already on the bottom of this beaker, there was liquid nitrogen here 2 seconds ago, and it's not even there anymore. So all right, so it went into the balloon, and it needed more space than that, so it popped away. So there's a free balloon for anybody who would like to have it. All right, so let's look at some other cool things. What I'm going to do next is I'm going to pour a little bit of liquid nitrogen into my styrofoam cup because this is very, very heavy. Another question we typically have is, why do you use a styrofoam cup, or what's the best kind of way to have to hold liquid nitrogen if you're not going to hold it in a dewar? Styrofoam is a really good insulator, so that means it holds heat very, very well if something's a good insulator. So typically, if you go to a gas station and get a hot coffee, they're not going to give you a hot scalding coffee in a plastic cup because plastic is not a good insulator. But styrofoam is. Same with something very, very, very cold. All right, next thing I'm going to show is our little egg that we have right here. I'm going to pour this water into this bowl. And right here, our egg is on top of the beaker, and all of a sudden we have a very, very all right, so the egg was very, very, very cold, and all of a sudden there's a huge temperature difference because I poured water very quickly, this is very hot water, into another bowl. And if you could look, the egg is slowly coming back up. So what happened was that because the egg felt that very cold temperature, all the molecules in the air around it all of a sudden got really close to one another. So imagine that you're cold and you want to snuggle up in a sweater or a blanket. Same thing with the molecules. And now all of a sudden it's really hot because of this hot water, and the egg is coming back up the beaker because you're taking your sweater off, your blanket off. I don't want anything on me. I'm too hot. So the molecules are getting far away from one another. The next thing we know, our egg went from the top all the way, it almost dropped to the bottom of our beaker, and now it came back up again. All right, so now it'll completely freeze in that liquid nitrogen. All right, so what else do we have here? Let's put some more liquid nitrogen in our really good insulator, which is a styrofoam cup. And let's look at this tea kettle. I'm sure many of you at home have boiled some tea in a tea kettle. I know that I have. Usually it takes you about 5 minutes to boil water. Because liquid nitrogen boils off right away as soon as it leaves the dewar and I pour it out, it expands 696 times. So that kettle's going to boil right away. If anyone would like some tea, we're going to have it right here. Just kidding. It's very dangerous. Don't ever drink, ingest liquid nitrogen. It's just something fun that we say for show. All right. So another little cool experiment we would look at is our ball and loop. This is a metal ball and loop. So what's happening here is at ambient temperature, which is the room temperature that we're in right now, it's about maybe 73, 75 degrees in this room. The ball goes right through the hoop, right? So we're going to learn a little bit about thermal contraction and thermal expansion. So it occurs when you cool a material down and the atoms don't have much energy anymore. So when I put it right here in our liquid nitrogen, I'm just going to use it over here where our egg was just at a second ago. I'm going to pour a little bit of more liquid nitrogen. By the way, it's always constantly boiling off just because of the temperature difference. All right, so what happens here now, when you heat a material, now when I take these out, this is thermal expansion right here. We have to wait a few more minutes. Right here. So this is thermal contraction. It's frozen and it won't go through. So thermal expansion is when you heat a material and it gains internal energy, and therefore the atoms within the material move faster and the material expands. So now it won't go through the ball like it did before because it expanded. That energy expanded. The internal energy is moving away from one another. Another good way why some companies would use it, so some facilities, if they have like a nut and bolt on a big machine and they need it to screw in and go in properly, they might use some liquid nitrogen just so the metal or the material of the nut or bolt will expand, and then they'll push the nut and bolt through, and if you look now, it expands. So then they would have a really tight fit on a screw, a nut and bolt, or anything like that. So it's used a lot for hardware purposes. All right, what else do we have here? Let's see how a tornado works. That's always fun, right? It's usually fun maybe to see from afar or on TV, but I sure don't ever want to be in one. All right, so we have hot water here. And then we have liquid nitrogen right here. So let's talk about how a tornado works. Usually in April, right, is when it's the end of springtime and the beginning of summer. So that's usually when you see the most tornadoes. And where do you see tornadoes mostly? You see them in maybe the Midwest or the middle of the United States, so states like Kansas, Oklahoma, North Texas, Arkansas, some parts of Tennessee, some parts of Illinois, they usually get hit a lot with tornadoes. So what happens is during April, the really cold air that's coming from up north from the northern states, from Canada, Minnesota, the northern states, are coming to the middle of the United States, into those states. And then the states that are from down south that are really, really hot, that hot air is moving to the middle of the United States as well. So when you have that cold and hot air and they meet one another, they get very, very angry. And when there's a vortex spinning at the same time, you might see a tornado. So I won't have a real tornado demonstration here because something might get broken, but I have a really cool little demonstration that a group of 4 7th graders from Tullahoma, they made this for a science fair project and they donated it to us. So if I have hot water and liquid nitrogen, it's got very extreme temperature differences, and up here is a fan. We just made a tornado. So that's a lot more fun, really cool, a really safe way of demonstrating what a tornado looks like from different temperature winds and how they spin together in a vortex than it would be seeing it in your backyard. All right, so that will just boil off right here. All right. Actually, I hope no one at home minds. I didn't really get a chance to eat today. Well, I didn't have some lunch, so if you don't mind, right in the middle of this show, I think I'm going to have a little snack. You know, I got some Cheetos on the way here. And wouldn't it be a lot more fun and a lot more tastier to eat Cheetos with some liquid nitrogen on them rather than just eating Cheetos from a bag, right? Sorry, okay, I'll get back to what I'm doing. Sorry, it was just so delicious. Ooh. It's cold, but it's really good. It's very crunchy. I might get hungry later. I might have another Cheeto again later. So another question that a lot of folks might have is, so what else is liquid nitrogen used for? We could use it to heat and have thermal expansion of different materials for different tools and different screws, bolts, and nuts, so they can screw in together. We could use it at the doctor's office. Is there any way else that we might use liquid nitrogen? There is. A lot of fast food places might use liquid nitrogen to quick freeze their patties to put them on a truck and go them somewhere. And a lot of people, they might think, oh, liquid nitrogen in my food? I don't know if that really sounds like something I'd want to eat after. Well, I just had 2 Cheetos for a little snack, and it was really, really good. And all I did was I just let the liquid nitrogen boil off, because it's meeting that warm temperature air, and then it's safe to eat. So liquid nitrogen used to quick freeze patties, like hamburger patties and whatnot, is very safe because it slows down the metabolism and it doesn't actually kill off a burger or kill off the healthy cells that are in a burger. So they're very safe to use. Where else can we see liquid nitrogen? A lot of clinics and in the medical world, other than just getting a wart off your back, a lot of cells are used to freeze. You could freeze a cell, like specifically like a reproductive cell. So if somebody wants to have a baby later, but they know they have healthy cells now, they can save their cells, put it in a little scope like this, and put it in a huge dewar, and the first few years of a baby's life might be in a big liquid nitrogen dewar. Once again, nothing is killed off. The metabolism of the cells are just slowed down a little bit, but that's a good way to freeze and hold to cells for a very, very long time. So it's very, very important in the medical world, in the fast food world, in many different facilities as well. So what we have here for a finale is, well, before I go today, I'm going to teach a little bit on, because I think everyone at home needs to know, is how to wash dishes. Because I'm not great at it. I'm a little better at it now since I have to, clean up after my kids all the time. But sometimes, you don't know the right way to do it. A little tip is that you don't have to use a lot of water, even though it might help, but you probably don't want to, because you want to save water to not consume as much and save our planet. But you only need a little bit. You only need a little bit of dish soap. So once again, we are going to use hot water, a little bit of dish soap, and some liquid nitrogen. Woo! There we go. So there you have it, kids. Just use a little bit of dish soap, and look how much soap you have to wash all your dishes. So you can help your parents and wash the dishes after dinner time one night. The only not fun part is cleaning it up. So there you have it, folks. That is some really cool properties of liquid nitrogen, and that's just one of a million different topics and fields of science that I really love. This is liquid nitrogen, and what it's part of is cryogenics. Cryogenics is the study of how materials behave under very, very, very cold temperature differences. So that is our liquid nitrogen show. If you want to see more, go on our Facebook group and search Hands On Science Center, or you can go to hosc.org. And thank you so much for having us today at the Williamson County Public Library, and we hope to see you soon.